Reporters and topics. Ba ako Carlito D. 3rd J, Polymorphism and Concepts. Bukar Jaric E, Polymorphism and Applications. Enanor J. Bapi, Overloading. Morales Macy Ann V, Overloading Example. Tantay Lerma Jean A, Overriding. Panambulan Abigail S, Overriding Example. Hi, good day. I'm Carlito J. Paako III, and I will be discussing the polymorphism and concepts. Polymorphism is derived from two Greek words, poly and morphs. The word poly means many, and morphs means forms. So it means that the word polymorphism is having many forms. In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. At this point, let me give you an example of a real-life polymorphism. A person at the same time can have different characteristics. Like a man at the same time is a father, a husband, and an employee. So it concludes that same person possesses different behavior in different situations. In Java, polymorphism is mainly divided into two types. First is the compile-time polymorphism. It is also known as static polymorphism. This type of polymorphism is achieved by function overloading or operator overloading. But Java doesn't support operator overloading because it's just a choice made by its creators who wanted to keep the language more simple. Later on, Ms. Japa will discuss to you more about compile-time polymorphism. Second type is the runtime polymorphism. It is also known as dynamic method dispatch. It is a process in which a function call to the overwritten method is resolved at runtime. This type of polymorphism is achieved by method overriding. Later on, Ms. Lerma Jean will discuss to you more about runtime polymorphism.
Next topic naman tayo ngayon guys, which is yung polymorphism application.
Ano yung polymorphism? Tingnan natin. Polymorphism is one of all the pictures that allow us to perform single action in different ways. So parang sa iba-ibang paraan, yung isang action lang. Example, meron tayong class animal na may method na sound. Since generic class itong animal, hindi natin siya pwede lagyan ng roar, meow, oink kasi ang generic class lang. So, sound, animal is making a sound. Hindi siya pwedeng arf, hindi siya pwedeng bark, or meow, kasi nga, generic class pa siya, hindi pa siya as in yung specified na animal yung nilagay natin. Hindi naman tayo pwede maglagay ng anong sound lang sa isang animal kasi hindi naman natin na specify. Lagay tayo ng ibang example. Dito may class dog tayo na inherit si animal, yung tapos override, tapos arf. Yung override is para siyang picture ng OP kung saan yung child class pwede siyang magbigay ng ibang implementation sa isang method na na-define na sa parent class. So parang dito iniba niya si public sound, ginawa niyang animal is making a sound, ginawa niyang arf. Tapos yung sa baba is paano na siya i-output, parang ganon. Dito naman si cat naman, in-extend din niya si class animal, tapos in-override si sound ulit, nilagyan ng meow. Kasi cat na yung binigay natin na animal. Hindi na siya generic class kasi nga nagbigay na tayo ng specified na animal, which is si cat. Kanina generic class na yun kasi animal yung tinawag natin. May iba-iba na mga sound yung mga animal, hindi lang meow, diba? Kasi hindi naman magsasabi ang aso ng meow, hindi rin tatahol yung ibon. Parang ganun yung ano niya, parang yung logic ba. Tapos yung sa baba is paano lang din siya i-output. Kahit na may something in common action lang sa lahat ng subclass na meron tayo, iba-ibang paraan naman yung ginagawa ng action na yun. So yun na example ng polymorphism. Yung isang action nagagawa natin sa iba-ibang paraan. Hindi naman siya mag-make sense kung yung generic na sound ng animal, kasi may iba-ibang sound naman lahat ng animal. So yung polymorphism is magdedepende din siya kung anong klaseng object yung ibibigay natin. Sa example, na-define tayo ng dalawang method na sound, tapos na-implement siya sa dalawang subclass. So yung method na yun is malalaman lang natin pag i-run natin yung program. So example yun siya ng runtime polymorphism, kasi malalaman naman natin siya pag i-run natin yung program. Doon na natin ma-base kung ano yung i-output niya.
Good day. So now, I am going to discuss method overloading in Java, or overloading. What is overloading? Overloading refers to multiple methods that has the same name but different parameters. A method can have the same name as long as the number and or the type used for parameters are different. Let me show you an illustration how overloading can be pictured out. Let me also show you an example where the function has same name but different in numbers and data types. Here it is. A function named myMethod has 3 overloading methods, which is integer myMethod, float myMethod, and double myMethod. But the number of parameters used are different. The first 2 functions used only 1 parameter each, while the third function used 2 parameters. Thus, overloading is related to compile time static polymorphism, because overloading is used to enforce type checking in function calls during compilation. When a method is overloaded, the method chosen will be selected at a compile time. That means that method overloading is an example of static polymorphism. It is because that the method used would be called is determined by the parameter list at the compile time. That's why it is known as compile time polymorphism. There are different ways to overload a method. Number 1, number of parameters. Number 2, by the data type of parameters. 3, by the sequencing of the data type of parameters. Number of parameters. The method is overloaded based on the number of parameters, where both are having different number of parameters used. For example, the first method used 2 parameters. The second method used 3 parameters. That is how overloading can be executed with the number of parameters. Second is data type of parameters. The method is overloaded based on the data type of parameters. For example, in the first method used, both parameters used integer data type, and the second method used integer and float data type. The last but not the least is the sequence of the data type of parameters, wherein the method is overloaded based on the sequence of the data type of parameters, which both methods have different sequence of data type in the parameter list. Now, let's proceed to the advantage of method overloading. First, we don't have to create and remember different names for functions doing the same thing. The second advantages of method overloading is to provide code clarity, eliminates complexity, and enhances runtime performance. And for the disadvantage of method overloading, the method overloading is not possible by changing the return type of the method only because of ambiguity.
Example of overloading in Java using netbeans. One of the overloading example is overloading by changing the number of parameters. In Java programming, overloading can happen when you create a function and their variable name is the same, but the arguments inside the parameter is different. Let's say, for example, we have a class here, overloading example 1. In the first function, we are getting the sum of 2 integers, and the variable name here is sum, and the integers inside the parameter are only 2. So let's proceed to the second function. Now, in the second function, we are getting the sum of 3 integers, but the variable name is also sum, but the parameter, inside the parameter, we only have 3 integers. That's why we are getting the sum of 3 integers. So this is where overloading happens. The parameter of the functions are different, but their variable name is the same. Let's proceed to the second example, which is overloading by changing the data type. In Java programming, overloading can also happen when you create a function and their variable name is the same, but the data types are different. So let us now focus on the third function. So the first two functions, we have the data type integer, but in the function number 3, we can now see that the data type was changed into double. It is also possible to have the same variable name, and it is considered as overloading, but make sure the parameter is different. Now, let us call the function inside our main. This is where compile time happens. We call our function and we give the value of each function to run to our program. So let's say, for example, let's get the sum of the first function. Integer x is equals to 100 and int y is equals to 500. In second function, we have x is equals to 100, y is equals to 500, and integer z is equals to 1000. Lastly, let's get the sum of the double. Double x is equals to 1.5 and double y is equals to 2.5. Now, let's run the program and see what will be the output. And the output are 600, 1600, and 4.0. Another example of overloading is sequence of data type. In Java programming, overloading is also possible on a sequence of data type inside the parameter. As you can see, I added two functions, which is the first function's name is sample, but the parameter is an integer and a string. And to the last function, its variable name is also sample, but the parameter is a string and an integer. This is where overloading happens. It has the same name, but the sequence of data type is different. In the first function is an integer, then a string, and to the last function, it is a string and then integer. So let's call the function. So the function's name is sample. Inside the parameter, we need to include first the integer and then the string. So 15 and then sequence method. In the second function, we need to call the function's name, which is sample, and then we need to include the string and then integer. So sequence, then 15. The output will be 15 sequence method and 15 sequence method.
A pleasant day to everyone. My name is Lermajin A. Tantay, a student of BSIT 2B, and I will be discussing about the method overriding in Java. To start with, let me show you my presentation of this topic. Method overriding in Java. In any object-oriented programming language, overriding is a function that allows a subclass or child class to provide a particular implementation of a method that is already provided by one of its superclasses or parent classes. That is, overriding is a feature that provides a specific implementation that is provided by a parent class or a superclasses. Method overriding is when a parent class reference points to the child class object, then the call to the overridden method is determined at runtime. Because during method call, which method of parent class or child class is to be executed determined by the type of object. In this process, in which call to the overridden method is resolved at runtime, that is known as dynamic method dispatch. Runtime polymorphism, known as dynamic method dispatch, is a process in which a call to an override method is resolved at runtime rather than compile time. This process, an overridden method is called through the reference variable of superclass. Advantages and limitations in method overriding in Java. The main advantage of method overriding is that the class can give its own specific implementation to an inherited method without even modifying the parent class code. In this advantage, this is helpful when a class has several child classes. If a child class wants to use the parent class method, it can use it, and the other classes that want to have different implementation can use overriding method to make changes without touching the parent class code. Limitation of Java method overriding: cannot override static methods. Only instance methods can be overridden. Cannot override constructors. Overriding method cannot throw check exception wider than the exception thrown by the overridden method. If the overridden method doesn't throw any exception, overriding method can throw any exception. Cannot reduce the visibility of the overridden method. Means, if the method in base class is public, it cannot declare private in derived class or subclass. If a method cannot be inherited, it cannot be overridden. So private method cannot be overridden. Rules for Java method overriding. Rule number 1. The argument list should be exactly the same as that the overridden method. Overriding method should have same syntax and return type as overridden method. If the number and type of arguments varies, it becomes overloading. If the return type is different, then compiler gives compilation error. Rule number 2. The return type should be the same or a subtype of the return type declared in the original overridden method in the superclass. Rule number 3. The access level cannot be more restrictive than the overridden method's access level. If the superclass method is declared public, then the overriding method in the subclass cannot be either private or protected. Rule number 4. Instance methods can be overridden only if they are inherited by the subclass. Rule number 5. A method declared final cannot be overridden. Rule number 6. A method declared static cannot be overridden but can be redeclared. Rule number 7. If a method cannot be inherited, then it cannot be overridden. Rule number 8. A subclass within the same package as the instance superclass can be override any superclass method that is not declared private or final. Rule number 9. A subclass in a different package can only override the non-final methods declared public or protected. Rule number 10. An overriding method can throw any unchecked exceptions regardless of whether the overridden method throws exceptions or not. However, the overriding method should not throw check exceptions that are new or broader than the ones declared by the overridden method. Rule number 11. The overriding method can throw narrower or fewer exceptions than the overridden method. And lastly, rule number 12. Constructors cannot be overridden. Overloading versus overriding. In method overloading is used to increase the readability of the program, while method overriding is used to provide the specific implementation of the method that is already provided by its superclass. In method overloading is performed within class, while method overriding occurs in two classes that have is-a inheritance relationship. In method overloading, in case of method overloading, parameter must be different, while in case of method overriding, parameter must be the same. Method overloading is the example of compile time polymorphism, while method overriding is the example of runtime polymorphism. In Java, method overloading can't be performed by changing return type of the method only. Return type can be the same or different in method overloading, but you must have to change the parameter, while in method overriding, return type must be the same or covariant in method overriding. This is the illustration of the differences between overriding and overloading. Overriding, as you can see, same method name and the same parameter, while in overloading, they have the same method name but different parameter.
Hi, I am Abigail Santos Panambulan from BSIT 2B. In this presentation, I'm going to show you some simple example of method overriding. First, you should be familiar with the term parameter and overriding. parameter is a variable in the method definition. When a method is called, the data of the arguments are passed to the method's parameter. Overriding refers to the ability of a subclass to re-implement an instant method inherited from a superclass. So, let's dive in and understand method overriding in Java. Example number 1. In this program, the displayInfo method is present in both the animal superclass and the dog subclass. When we call displayInfo using D1 object, which is object of the subclass, the method inside the subclass dog is called. The displayInfo method of the subclass overrides the same method of the superclass. Notice the use of @override annotation in our example. In Java, annotation are the metadata that we use to provide information to the compiler. Here, the @override annotation specifies the compiler that the method after this annotation overrides the method of the superclass. It is not mandatory to use @override. However, when we use this, the method should follow all the rules of overriding. Otherwise, the compiler will generate an error. Example number 2. In this example, the subclass dog overrides the method displayInfo of the superclass animal. When we call the method displayInfo using D1 object of the dog subclass, the method inside the dog subclass is called. The method inside the superclass is not called. Inside displayInfo of dog subclass, we have used super.displayInfo to call displayInfo of the superclass. It is important to note that the constructors in Java are not inherited. Hence, there is no such thing as constructor overriding in Java. However, we can call the constructor of the superclass from its subclasses. For that, we use super. Example number 3. In this example, the subclass dog overrides the method displayInfo of the superclass animal. Whenever we call displayInfo using D1, which is object of the subclass, the method inside the subclass is called. Notice that the displayInfo is declared protected in the animal superclass. The same method has the public access specifier in the dog subclass. This is possible because the public provides larger access than the protected. So, in conclusion, the benefit of overriding is the ability to define a behavior that's specific to the subclass type, which means a subclass can implement a parent class method based on its requirement.
Reference used.